I'm Greg Olick Sr. from E3 Med-Acoustics, and today I'm going to talk about the AudioScan Verifit2. We call it the Verifit2 because it's the second generation of Verifit. The original Verifit, or the Verifit Classic, was the leader in the industry for real ear measurement and test box, hearing aid test box function. So this is the new Verifit2. You can see it looks a little bit different than the Classic, if you've seen that, and they've made significant improvements in it. For one thing, there's only one menu rather than multiple menus, and that same menu is used for test box measurements and real ear measurements, and you get that menu back anytime you right click on the mouse. Everything is done with the mouse, and it can be operated remotely. In other words, you don't have to have it totally separate from your computer. It can be linked to your computer via your network, and you can use remote software, which is no cost, comes with it, the remote software to actually see the screen of the Verifit on your computer, the same computer that you'd be using for the fitting software, and you can control the Verifit from your computer rather than going back and forth between your computer and the Verifit. So it's faster, simpler to use, and it's cleaner. I'll show you several aspects of it that make it different. There's a better, more acoustically sound and acoustically isolated test box, and there is a less complex system of probes, so it's neater, not so many cords and things. You'll see all of that. One of the new features on it is a probe placement feature. For many people doing real ear measurements, especially doing real ear measurements for the first time, they have an issue with the probe placement, the tube in the ear. And so when you have this function on, and all you got to do is hit an icon whenever you're in the real ear measurement on ear function, and start putting the tube in the ear canal. When you do that, you get this. This is showing the location of the tube. At the moment, it's 15 millimeters from the eardrum. Well, that's not close enough. You want it within 5 millimeters of the eardrum. So as you put the tube further and further in the ear canal, that white dot moves further and further, so you know exactly how far you are in real time from the eardrum. And once you get it to the area that's within 5 millimeters, presto, you get a green check mark like that, and you know you have the proper and, in fact, ideal probe placement. Really a nice feature. Another new feature is this. This is a monitor of ambient noise. A lot of times people do real ear measurements in places where the ambient noise is really too high, just the background noise. And so it distorts the waveform, the hearing aid waveform, because it's not only amplifying the stimulus that's being generated from the system, but it is also amplifying the other ambient noise in the room. So this is quick and easy. If you got like this is the red is the ambient noise. And as long as it's low enough, this is telling you that you can accurately do soft speech at 50 dB, 55 dB, and of course average speech at 60 or 65 with no problem. And of course you could do loud noises and all of those other things. Here's a room where the ambient noise is way too high, so you couldn't do soft speech at any level, not 50 or 55, because it's going to be totally distorted by the ambient noise, and you couldn't even do average speech at 60. The best you could do is average speech at 65, and of course loud speech or loud environmental noise. So that's a good feature, just so that you can hit one icon and know the levels of ambient noise in the room in which you're doing real ear measurement. Notice also that the the cords for the real ear measurement system and the two probes are much neater. There's only one cable going to the system, and then it's connected to this module, and then both the right and left probe is plugged into the module. The module clips onto the patient's clothing, and then the probes are placed on their ears, and that part right there is then brought up just under the patient's chin, and it holds the probes flat on their cheek, under their ear, so that the reference mic is pointed out. And it's not, because people found that they would flip around and then they had the wrong orientation. So that's it's an excellent way to do it. If you don't want to clip it on, it also comes with a lanyard, and you can use a lanyard instead. The new Verifit 2 is also binaural. You can do binaural testing in a test box and binaural testing on real ear measurements. And so here I'm testing both ears at the same time, right? In this graph, this is a SP allogram. This is the level of normal hearing, this dotted line here. Then this green line is soft speech, and then average speech, and then loud speech, and loud environmental noises. So the idea is to get them close to their targets. These little plus signs that you see are the actual targets. So our soft speech is basically meeting target in at all of the frequencies, and so is our average speech. Loud speech almost meeting target, and then the loud environmental noise is meant to be kept below the UCLs, the uncomfortable loudness levels. So both ears can be done at once. You can run up to 4 curves per ear. That's what you see here. And to run them, you're simply hitting the go button, and I have it in the binaural mode. You can still do left and right separately, or you can do them together. If you did them together, you'd have it in that mode. You'd use the dual view, so you're looking at both left and right, and it would produce the curves like this. Again, you're running this not just on the screen of the Verifit, but you're also running it remotely on the screen of your computer, along with your fitting software, so you can manipulate the fitting software and manipulate the controls and watch the results of the Verifit at the same time. When it comes to the test box on the Verifit has always been very, very useful. I go to a lot of places where the test box is just a collection space for old batteries and paper clips and things like that, because it's never been used. Because test boxes for hearing aids really aren't practical in most places. Yes, the manufacturer has one, and of course if you're working in the VA or a university, you're going to go through a sequence of testing on every hearing aid that you order. But in the everyday clinic, not the case. But with the Verifit, the test box is very useful. These are the new couplers, and they're wideband couplers. Besides the Verifit 2 being a totally binaural unit, binaural in its real ear measurement, binaural in everything it does in the test box, but it's also wideband. So you're not just limited to, say, 125 through 8,000, it actually goes up to 12,000. And so the couplers are wideband couplers. You also have the conventional couplers for ANSI tests that require conventional couplers for behind the ear and in the ear hearing aids, but you do have wideband couplers, and you would do much of your testing with those wideband couplers. And you almost never have to use putty anymore, because there are some adapters that come with the system. And one of the adapters that comes with the system, these are simply holders for the hearing aids when they're mounted in the test box on the couplers. But these are called trick adapters, TRIC, that's thin tube receiver in the canal. And I'll show you in another slide how those adapters are simply placed on the couplers, and then there's a hole in the middle of it, and you put the receiver right through there, and you don't have to use the putty. A lot of people didn't use the test box because they didn't want to go through all that coupling with the putty for every hearing aid. And of course, these would be the adapters for behind-the-ear hearing aids. Now, if you had a custom ear mold still and you wanted to putty it, you still could. Comes with putty. So the test box part of this system is very practical. Unlike test boxes of other systems and test boxes of the past. A lot of times, a hearing aid test box in clinics, real-world clinics, private practices, ENT practices, even pediatric practices, isn't really used. I've been to places where I've opened that up and it's just a storage place for old batteries, paper clips, all kinds of stuff. In fact, there's a lot of dust in there. But this is a practical test box. And these are some of the things, practical tests that you can do in it. Okay? And first of all, of course, would be simulated real ear measurement fittings, and we use the SpeechMap method of real ear measurement, of course, but simulated real ear measurement fittings for pediatric patients. Some pediatric patients, and in fact, almost all pediatric patients, you can't run standard real ear measurement on because they're not going to sit still as you put a probe down in the ear and then put their hearing aids in on top of the probe tube. So maybe you can measure the real ear to coupler difference, and this allows you to do that within seconds. That's if the patient will tolerate that. If they won't tolerate that, then this system will do simulated real ear measurement, and it'll do it in the proper way. Naturally, trying to simulate the ear of, say, a 6-month-old baby in a metal coupler is a mortal sin. You can't do it. However, because of the work that was done for decades by the University of Western Ontario in connection with AudioScan and the Verifit, it can be done accurately. And it really is because the statistics use such a high N factor, or number of cases. So they have norms on literally tens of thousands of patients. So if you can't measure real ear to coupler difference, you can't do real ear measurement in the ear, then what you do is simulated real ear measurement in the test box in the couplers. And you simply put in the patient's age. And all ages are in the system from 3 months old all the way up to 10 years old in 1-month increments. And so you have a very, very accurate simulation of the patient's ear for their age in this in the couplers. So simulated real ear measurement in the test box, done binaurally, no problem. There's also an adaptive directional microphone test. I'll show you that screen, but that's where you actually can see very clearly the effect of a directional microphone. Do you have what's the difference between front and rear? If you're using a directional microphone because you know the patient will benefit from that because this person speaking to them is in front of them. We've even had cases where the hearing aid uses 2 microphones, one oriented towards the front and one to the rear. It uses that to acquire a signal-to-noise ratio, front-to-rear ratio. What if they're miswired at the factory? The patient actually hears better from the rear than they do the front. And you wonder why they're not learning anything if it's a kid in school. So you would actually be able to tell that right away with this test. There's also a noise reduction test where you can play a noise, and the one I use is a vacuum cleaner, and you see instantly the response of the vacuum cleaner, and then as you wait and the hearing aid figures out, oh, that's a vacuum cleaner, not speech, then you see the noise go down, right? So that reduction in noise and the difference between initial and then the reduced level is the dynamic noise reduction. And also a dynamic test of fidelity or distortion done in 1/3 octaves. And you can do this at different levels. You do it at conversational speech, 65 dB, and loud speech. Suppose they say, my hearing aid doesn't sound clear, and you run dynamic distortion tests all through the whole frequency range at conversational speech, and they say, well, I'm okay when I'm talking to you in a quiet place like this, but when I go into the office where it's noisy, then you know, nothing's clear because everybody's yelling in the office. Okay, well, let's do it at 85 dB. People are yelling because they have to get their voice over the voices in the background. Other people talking, copy machines running, things like that. Well, is now the distortion off the scale, or is it still good? Modern digital hearing aid at both 65 and 85, I find 0 to 1%. So then you know for sure that it's not that their fidelity issue is in the hearing aid. It's a really good way to do it. Dynamic battery drain test, where battery drain is done at 3 levels. It's done at what they call quiescent or quiet, and then at conversational level, 65 dB, and then done with an input of 90 dB, right, through the whole frequency range. Oh, well, it's just done at 1,000 hertz, sorry. And so you see the battery drain under those 3 different conditions, quiet, conversational, and loud. And a good hearing aid with good current regulation, you should have about the same in each one. It shows good current regulation. That's typical of modern digital hearing aids. The older analog hearing aids with the loud input, 85, 90 dB, the battery drains off the scale. And you can immediately tell whether the current drain is appropriate or whether it's really eaten batteries and needs to go back to the factory. Otherwise, there's really no way to know. And then there's another test I do. I'll show you this one. It's simply a very fast multi-curve test. In other words, we're just looking at the output curve of the hearing aid, frequency response of the hearing aid, and the level of it under multiple conditions. I typically do it at 50, 60, 70, and 80, even 90 dB. And what do I expect to happen? I'm looking at gain curves, right? I expect the gain to go down as the input goes up. And if it doesn't, then the compression's not working. So I can really tell right away. So these are practical tests that people can use all the time. When people come in, clients come in and they tell you it doesn't sound clear, it's eating batteries. When you think there's a problem, you really need directionality in a directional microphone. Well, some makes and models, it's no good. There's hardly any difference between front and rear. On others, it's excellent. So all of these things are very practical tests that you can do in the test box. I'll give you an example. This is the directional microphone test. And here you're looking at front and rear, right? And this is exactly what you want. If you've got a really good directional microphone, then front and rear. Front is this thicker curve, and that thicker curve, of course, is above the other curve. That thinner one is the rear, and you see good separation, right? Especially in the mid-frequencies, even in the highs. This has got really good directional microphone on it. If they were superimposed, of course, you would know that there was essentially no directionality. Either it's turned off in the software or it's just ineffective. And if it's miswired at the factory, then these are reversed. The thin ones on top and the thicker ones on the bottom. You'd have no way to know it if you were unable to do this test. Same thing with the battery drain and the distortion too. Sometimes the distortion is obvious. Well, you just listen to it and you say, yeah, it's going back to the factory. But sometimes it's not. They say that it's just not as clear as their old hearing aid or something like that. And there's a mound of distortion at a certain frequency or in a certain frequency band, and you couldn't really tell by just listening to it. Okay? But they pick up on it. Here's where we did those multiple gain curves at different intensities, right? The first two up here on the top are gain curves that were done at 50 and 60 dB, not much difference. But then when we raise the input to 70 dB, we watch that whoop just fall right down. Moved it up to 80 dB, it fell down more. If we moved it up to 90, it would fall down even more. And we can see that the dynamic compression is working the way it's supposed to work, right? Patient has a high threshold, and then you make the output much higher, or the gain much higher, and now you're in the uncomfortable range. So we have to squeeze speech into their usable area, and of course we're going to do that through compression. And it's good to know in a hearing aid, is that working? Because there are situations where it's not working, and of course there are makes and models that do a much better job than other makes and models with that particular test. So when the hearing aids are in the test box, this is how they're set up. I have both the left and the right one set up. They're both in the holders, just to hold them in the right place so that they're oriented correctly for the speakers that are in the test box. And then, as you can see, this receiver in the canal is plugged right into the trick adapter without any putty. Finally, I'd like to show you this. This is what they call their NOAA link. It's the Verifit NOAA link. So you have this system running on your network, and it's running under NOAA, and you just click on this NOAA link for the Verifit. Just click on the Verifit in NOAA, just like you would click on any of the fitting software that you had in there, and you get a screen like this. And then you can click on the patient's audiogram and push that arrow, and you'll send the audiogram to the Verifit. So you don't have to do like we did before, where you're entering that audiogram in each time. It'll send those over. And then when you're done, you've made all of your measurements, and then simply click the other one to download from the Verifit to the computer all of the measurement data. And at that point, you can print it to any printer that's on the network, or you can save it electronically. It's saved as a session under that patient within NOAA. So that's the AudioScan Verifit2 in a nutshell. It is the most popular, so it's the standard of the industry as far as real ear measurements goes and test box functions. It does all the test box functions that I talked about, and it does the conventional test box function also of running those ANSI tests, and you would do that in the ANSI coupler. But the things that I mentioned are what people do most in the test box because they are the most practical things. So I hope that helps you understand the AudioScan Verifit2, and if you have any questions, don't hesitate to let us know. Thank you.